Assalamu alaikum and welcome to DSP lectures. My name is Kanat Ishwaq and my enrollment number is 16TE35. In this lecture 3, we will basically focus on systems. The contents of our today's lecture are system and its type, what is system and what are its types, linearity and superposition theorem, how they are related to each other, time invariance, and some basic signals. Now let's see what are systems. Systems is the process that is used to produce or create another signals. That is, we take some input, perform some functions on it and produces some output. For example, if we consider that x of n is a signal, it passes through a system and produces some output. For example, considering y of n is our output y of n, and x of n is 3 times x of n. It multiplies x of n, some function with 3. It passes through this system and produces the desired output, that is y of n. Now next topic is the types of systems. Basically, systems are of two types, that are causal systems and non-causal systems. Causal systems depends on the present value or the past value, and non-causal system depends on the future values. I will explain you. Now let's see what's the point of difference between these two systems. Causal system and an acausal system or non-causal system. When our output is dependent on the input, that is current value, and its previous value, then we can say that our system is causal system. Contrary to this, if our output depends on the only future value, then it is an anti-causal system. Taking its example, for example, we can say that xt minus 1 plus x of t is a causal system. For example, if we take t as 3, then x3 minus 1 plus x of 3, that is x of 2 plus x of 3, that is, it is the present value, and this is our past value. So by definition, we can say that our system, that is our output, it is equal to our output, is dependent on some present value and some past value. So we can say it is a type of causal system. On the other side, if we can say that x of t is equal to x of t plus xt plus 2, taking t as 3 here also, so x of 3 plus x of 3 plus 2, x of 3 plus x of 5. This is our future value. Whatever value we will give, it will give us some future value. For example, if we put t is equals to 4, then here x will be 6, x of 6, that is also the future value. So we can say that is a non-causal system. But we can say that non-causal system, as from this example we can depict that non-causal systems contain some future samples. There are future samples, so it is not practically applicable. Let's solve these examples to see either this system is a causal or non-causal system. as y 1 by 5 will be multiplied by whole this term, so we are taking it common. X of minus 2 n minus plus 2 plus x of n plus 1 minus 1 plus x of n plus x of n minus 1 plus x of n minus 2. Let's analyze this system. This system has some previous values and minus 2, some past values. These two are the past values. This is the present value, that is, it is depending on a previous value as well as past value. But at this point, this plus sign indicates that it also depends on some future values. Future value, present, and this is some past value. So because of this, we can say that the given system is a non-causal system. Heading towards our second topic of this lecture, that is, system can be linear system or non-linear system. For linear system, there are two properties that should be fulfilled, that is homogeneity and additivity. If these two properties are satisfied, then we can say that our system is linear, or else our system is non-linear. Let's see what is linearity. If a system is homogeneous as well as it follows the additivity property, then we can say that our system is linear. Now let's see what is homogeneity or what is a homogeneous system. For example, if we take an input signal, x of n is an input system, it passes through some system and produces an output. And if we scale a system at the input side, that is scaling, we are multiplying our input with some factor. If this factor appears at the output side too, then we can say that our system is homogeneous. Now let's see the second property, additivity property. If we take two signals, that is x1 of n and x2 of n, these two systems are simultaneously passes through two systems and produces some output, that is y1 of n and y2 of n. If we add these two systems, x1 of n plus x2 of n, if they pass through a system and their outputs are added to, that is y1 of n plus y2 of n, then we can say that our system follows the additivity property. Now let's see what is linearity. Linearity is an amalgam of these two systems, so we can say taking two signals and multiplying with some factor or scaling it with alpha and beta. These two appears at the output side too. Now let's add them, as we have already scaled them. So next step is adding plus beta x2 of n. If this appears at the output side too, that is alpha y1 of n plus beta y2 of n, then we can say that our system is linear. If any one of this property is not satisfied, then our system is not linear, that is, it is non-linear. Let's see that either this function y of n is equal to x of n minus 2x of n minus 1 is linear or not. Before heading towards linearity, let's see either this function is causal or non-causal, as it is depending on present value and past value, so we can say that it is a causal system. Now for linearity we have to check for first the system is homogeneous, and then for additivity property. Now let's see whether the system is homogeneous or not. For checking homogeneity we will have to do the scaling. We will multiply it with some scaling factor. The scaling factor here we took is alpha, and we are considering that as z of n is equals to alpha x1 of n, the output will be y1 of n. So in doing this process we will say that z of n will be equal to z of n minus 2 times z n minus 1, as z of n is equals to alpha 1 x1 of n. So after passing through the system, it will gives us alpha x1 of n minus 2 times alpha x1 of n minus 1. Taking common, alpha x1 of n minus 2 x1 n minus 1. As x of n minus 2x of n is equals to y of n, so we can say that alpha is equal to y of n. So a system is homogeneous. If we consider that alpha multiplied it with factor y of n, that means that alpha x1 of n is alpha y of n. That is, our system is homogeneous. Now let's check either the system follows the additivity property or not. There is my pen. Again, now here we are considering that z of n is the summation of these two signals, that are signal 1 x1 of n and x2 of n. When this passes through the system, then it gives us output, and this, let's consider that it is equal to y1 of n and it is equals to y2 of n. Now as replacing in the function z of n is equals to z of n minus z2 n minus 1. Now let's do the calculations. Placing it with this, it will give us x1 of n plus x2 of n minus 2 x1 of n minus 1 minus 2 x2 of n minus 1. Combining the x1 terms and x2 terms together, x1 of n minus 2 x1 of n minus 1 plus x2 of n minus 2 x2 of n minus 1. As we can see that this portion gives us the output y1 of n, and this portion gives us the value y2 of n, and in the input side we have x1 of n plus x2 of n. So we can say that our system is additivity, that is, it follows additivity property. So as our system is homogeneous as well as it follows additivity property, so we can say that the given function is linear. If we say that our system is homogeneous as well as additive, then we can say it is linear. And if our system is linear, then we can say that it follows the laws of superposition. And if a system follows the law of superposition, then it is the superposition theorem. And superposition theorem is only be used with linear systems. And we can say that a linear system follows the laws of superposition theorem. And if we came to know that a system is if a system follows superposition theorem, then we can guarantee that it is a linear system, because a linear system follows the superposition theorem. Our next topic is time invariance. As from the word we can judge that time invariance, variant mean varying or variance, and time invariant, we can say that when our system is independent of time, that is, it is not depending on time, then a system is time invariant. Let's see how this system is time variant. Let's give some shift to this system, that is z is equals to z n plus z is equals to x plus n naught, and the output is z of n is equals to z of n cube. Now let's see what would be the effect after giving it some shift. Giving some shift at this point n plus n naught. After giving some shift, our output would be like n plus n naught. So it is depending on the value of this. It's changing with the value of this. So it's a time variant system. Whether this function is time variant or invariant. Now, as we have done previously, z of n is equal to x of n plus n naught. In the next step, z of n plus n naught, we will replace where there is n with n plus n naught. We are giving some shift. 1 plus n naught minus 5. Our system will be like 2x n minus 5 plus n naught. That is shift is appeared at the output 2. Time change after changing time, output is same as the input. That is, shift is also appearing at the output. So we can say that it is time invariant. That is, it is not varying with time. The last topic or the last content of our today's lecture, that is some basic signals. There are two types of some basic signals. There are two basic signals. There are unit impulse signal and unit step signal. These both two signals are interchangeable. I will tell you later how these two signals are interchangeable. For unit impulse system gives value only at 0. At 0 its value is 1. At all other points this system is dead. Plus infinity and minus infinity. This signal is dead, and it can be written as del of n is equals to 1 0. 1 for n is equals to 0 and 0 otherwise. That is, for all other values it is 0, null. Unit step. For unit step gives us value unit step there. Unit step gives us value for gives value 1 for at n is equals to 0 and greater than 0, 1, 2 and so on. It gives us one value and we represent it as u of n 0 for n is less than 0 and 1 for n is greater than and equals to 0. So these are the main concept of these two major signals, that is unit impulse signal and unit step signal. As I have told you before starting this topic that these both two are interchangeable. How these are interchangeable? That is, if we derivate our step function, that is unit step function, it will give us impulse function, and if we integrate impulse we will get unit step. For example, if we derivate u of n step with respect to n, u of n minus u of n minus 1. Let's illustrate it with figures. This is an impulse function, unit step function. Till infinity, it's 1. And if we give it a shift of 1, that is not value at any value at 0 but at points greater than 1, and if we subtract these two values then we will get value only at 0 पे 1. That is, from unit step we are transforming our signal into impulse using derivative function. Now from impulse to unit step we basically integrate our signal. How we apply integration? Impulse function summation of n plus summation of n minus 1. That is, if we have value at here, this is alpha n, at this point we have forward value, alpha shifted value, and so on, then we will get an unit step train or impulse train and so on. Sorry for this figures. So we have transformed our signal from impulse to unit step by integrating an impulse signal. So summarizing this whole topic, if you want to convert impulse into unit step, what we do is we integrate, and from unit step to impulse we derivate. That's all for today's lecture. Thank you for watching. Allah Hafiz.